Assalamualaikum warahmatullahi wabarakatuh. Today we are going to speak about a heading called refractive index. In the case of refractive index, you can define the refractive index as a measure of bending of light during refraction. Okay, and it doesn't have a unit. If you look for the unit, okay, refractive index like relative atomic mass, relative molecular mass, okay, this also doesn't have a unit. In exams or books or somewhere, if you see the refractive index is equal to number 1, refractive index, okay, refractive index is represented in numbers. Okay, example 1.5, 1.3, 0.8, 1, okay, 2.4, like this. Okay, they are represented in numbers. Refractive index is represented in numbers. So if the refractive index is 1, some medium has refractive index equal to 1, then you have to decide light is not going to bend. Light will not bend. If the refractive index is greater than 1, something like 1.5, 1.3, 2.4, okay, like that, if this is a greater value than 1, then you have to decide, okay, light is going to refract towards normal. If the refractive index is less than 1, light will refract away from normal. Light will refract away from normal. Okay, if you notice, refractive index increases, the bending of light also increases. So sometimes you might think, what is this refractive index? I will explain you further, don't worry. But first thing it is, you want to have this knowledge. My children, in your syllabus, in your syllabus, refractive index of certain media are given. Okay, refractive index of certain media are pointed to you. One of the refractive index, I tell you, refractive index of glass with respect to air is 1.5. Refractive index of water with respect to air is 1.3. Okay, even I don't know the refractive index of diamond this side for it. Refractive index of diamond is 2.4. Okay, refractive index of diamond with respect to air equals to 2.4. So they have different refractive indices. Okay, so let's try to understand it further. For that, let's go for a diagrammatical representation. Here I take three interfaces. This is one interface, this is another interface, and this is another interface. Okay, three interfaces. In all the three interfaces, there is air outside. Here air outside, here also air outside, here also air outside. Below This is water with refractive index 1.3. This one glass with refractive index 1.5. This is diamond with refractive index 2.4. I am sending a light ray through the air here and draw a normal through the point of incidence. Okay, let's bring them to thick. Okay, I am doing the same thing to this one also. I am doing the same thing to this one also. Same light rays coming. Okay, here the arrows. Okay, so the light ray air to water, water 1.3 no, so towards normal. Air to glass 1.5 towards normal. Air to diamond 2.4 towards normal. All the ones are towards normal. Okay, in the towards normal, if this is the extended line, that is compulsory no, that is compulsory, right? Then only your diagram will be perfect. Perfection is very, very important in learning. Okay. So now all the three light rays are going to bend. Now say water's one is bending this way. Okay, water's one is bending this way. Glass is more in refractive index, so glass will bend more, bending more, bend, okay, bending more. Diamond very high, so it will refract very closer to the very closer to the, see the bending here 1.3 bending, 1.3 no, refraction is low. This is 1.5, okay, high value, 1.3 to 1.5 more. One point three to 1.5 is going to be a higher value. This is 2.4, so it is getting very closer to the so my children, hope you understood, all of you understood, I think, the refractive index. There are some more details that I have to discuss regarding refractive index that I will try in tomorrow's work. Jazakallah khair. Assalamu alaikum wa rahmatullahi wa barakatuh. If you have any doubts on this refraction, don't keep a second step.